Any software developer in Mexico can write a perfect email or Slack message in English using an LLM. Reading and listening, no problem. They've already spent hours poring over documentation and watching technical tutorials in English. What really sets people apart or holds them back is speaking. I'm building VoiceCard to help developers in Mexico and Latin America level up their spoken English and double their salaries. So meet Roberto Lopez, a 29-year-old React Native engineer from Oaxaca, Mexico. He's one of those guys that's been programming every day since he was 13 years old. He reads and writes English every day. He can understand technical documentation, respond to Slack messages, but when it comes to speaking, he freezes. He worries about his accent, gets stuck searching for the right words, and dreads video calls with international clients. Roberto and many other developers like this know that if they could speak English more confidently, they could land better jobs, lead projects, and double their salaries. Roberto needs a way to practice real conversations applicable to his job and efficiently level up his speaking and pronunciation. Speaking and pronunciation is hard. A lot of developers have a unique linguistic profile. They have high reading and listening skills, but low speaking skills. My hypothesis is that they need vocabulary and pronunciation instructions specifically tailored to the field of software engineering. Apps like Duolingo focus on generic learning solutions, so they may teach a learner how to say the cat is on the table rather than the pull request is closed. Existing products in the market don't focus on the unique linguistic needs of software developers. I'm hoping that VoiceCard can fill this gap by combining the scientifically proven method of spaced repetition with newer techniques in conversational AI. For those who don't know, spaced repetition is just a flashcard-based system where the words or vocab items you get wrong are the ones that you end up reviewing the most. I decided to focus this product on Spanish-speaking developers in Latin America. This is a massive and rapidly growing market. According to 2024 industry data, there are over 1.5 million Spanish-speaking developers in Latin America, with Mexico leading at nearly 1 million developers, followed by Argentina and Colombia. The so-called nearshoring boom is driving unprecedented demand. Remote applications from Latin American developers has increased by 285% in the last 5 years, and U.S. companies increased their year-over-year hiring in Latin America by 50% in 2023. It's a $20 billion market growing at a pace of 9% annually. Companies who participate are looking at 50 to 60% salary savings compared to hiring in U.S. tech hubs. And it's also true that this global economic phenomenon offers significant opportunities for LATAM engineers, but many times only those who can communicate effectively in English are the ones who can participate. In fact, almost half of Latin American engineers prioritize language learning over technical learnings. Everyone knows speaking proficient English directly correlates with career advancement and higher paying international opportunities. So with that in mind, let's get into the demo of VoiceCard.
Before we start, we need to analyze this user story and split it into smaller tasks so we can assign them correctly. Can someone read out the details of the story for us?
Yeah, I can break down the details of the story.
Great, please go ahead and share the details.
Alright team, we have completed the code review for the new authentication feature. I want to talk about our deployment strategy to avoid any issues with users. What are your thoughts on how we should proceed?
Let's deploy now.
I understand the eagerness, but I'd like to take a more cautious approach. Can you share any concerns you might have about an immediate deployment?
Yeah, let's roll out slowly.
That's a good idea. How do you see us implement?
Hey team, during the code review, we found a significant bug in the new API that we need to address before deployment. What do you all think should be our next steps?
I think we should fall back to a previous commit.
That's a reasonable approach. Have we made any specific plan?
Okay, so that is part one of the demo, and that shows the context activity in which people have to use target words in an appropriate context. Another type of activity that I developed is what I'm calling the native explain activity, where users have to explain what a word means in their native language.
¿Qué significa esta palabra o verbo frasal?
Significa regresar a un punto previo.
Excelente trabajo. Has entendido correctamente el primer sentido. Si necesitas...
And finally, so the bigger picture for VoiceCard is to integrate the practice sessions that you just saw in the demos into a spaced repetition system for each user. So for example, I've created this mock dashboard which shows a user's different vocabulary items that they might be working through. So as they complete these cards, they'll unlock new cards, and the idea is to have different vocabulary items for different users based on their level and whatever they're studying. Now let's get into the system architecture. So in the demo, you saw two types of activities. It turns out both of these activities are LiveKit agents, and we'll get into that in the next couple of slides. Quickly, the application itself is a Next.js application that's hosted on Vercel, and the only thing I wanted to point out about the Next.js application is the way it requests a token from LiveKit. So as soon as the user clicks the microphone button, as you saw in the demo, that triggers a request to the backend in Vercel to request a token from LiveKit, and it passes, importantly, some metadata to LiveKit, which contains information about which activity the user wants to engage with and what is the target vocabulary item. So LiveKit then returns the token back to the backend, and it ends up in the browser, and then the user uses that token from their browser to initiate a direct WebRTC connection with LiveKit. So as I said before, LiveKit receives the token, and then it extracts some metadata from the token, and then based on that metadata, it knows which agent to hand off to, either the context agent or the native explain agent. And while this is happening, in the meantime, the user's WebRTC connection is being established with LiveKit. And the way the LiveKit framework works is, first, it has a turn detection model. So LiveKit waits for the user to finish speaking, and then it has a speech-to-text transcription node, which is then passed into a main LLM node that generates the response in the conversation. And finally, that response is synthesized into speech. And so in this case, I chose to use Deepgram Nova 3 because I found it worked well in bilingual situations where users switch between English and Spanish, and also Google Speech to Text because I found it worked well to create more authentic sounding voices with accents, which is common in the tech industry, right? So importantly, VoiceCard has this on user turn completed hook. And the way this works is every time a user is done speaking, this hook is triggered. And this is where we insert custom business logic, or in this case, our agents. So these agents perform a type of RAG known as structured RAG. It's not actually going out and querying a vector database, right? We already know what the definition of these words is. And so the way it works is for the native explain agent, it synchronously checks to see if the user translated the word right into their native language, and then that informs the response of the main LLM node. Hey, you got this right, good job. And then in the case of the context agent, it's asynchronously checking to see whether they use the word appropriately in context, and then it's going to invoke a tool which causes the toast to appear in the browser via a GPC call. So what I did to test the context agent is I used deep eval to generate synthetic data for each lexical item that I was testing. So what I did is I created different responses where the user answered correctly, incorrectly, maybe they used Spanish, or maybe they had a grammatical error. And I used this as a first step in evaluation of the context agent. In this case, it was more appropriate to use deep eval instead of Ragus because of the fact that I'm using a structured RAG, and I didn't need to generate synthetic data based on a pre-existing corpus and embeddings. So I also used LangFuse to set up production tracing of the entire end-to-end conversation flow, and this allows me to monitor performance and latency across the entire conversation cycle. And also I can use this in the future to incorporate production traces into tests and evaluation in the future. So here is a screenshot of LangFuse, and you can see, for example, this is one trace of an agent conversation. So at the very top, I have the total duration of the session, the total cost and latency. And for example, here you can see I can break it down by individual nodes in the conversation lifecycle. To conclude, I believe there is a unique opportunity to create applications in the language learning space tailored to software engineers. And I'm building VoiceCard to help Spanish-speaking software engineers because this represents a $20 billion market opportunity. Thank you.